Hello, Houston. It's that time of year again where we're preparing for the hurricane season. This is Ken Graham, Director of the National Hurricane Center, right here in our operations area in Miami, Florida. Coming off the 2020 season, it was a record-breaking season. 30 named storms. We ran out of names and had to have an alternate name list. That's the most storms we've named in the 170 years of record keeping, and that's just a big reminder that we have to prepare for the upcoming season. When we go into 2021, we have to look at some of those hazards. It's about knowing your risk, mitigating that risk, and making sure you prepare your family for those risks. If you look at it, we have to listen to those local emergency managers, listen to those local officials. When they tell you to evacuate, well, you have to evacuate from those dangers. Historically, water, you're no stranger to the dangers of water with the heavy rainfall events of the past. 80% or more of the fatalities in these tropical systems historically comes from the water. Half of those in the storm surge itself along the coast, but as you know, it's not just on the coast. That inland rain, well inland, 27% of the fatalities can occur in that inland rain. So it's all about being ready, and in those fatalities with the water, half of those in automobiles. So always remember, turn around, don't drown. So here we go, 2021 hurricane season coming up. It's time to get ready, know that risk, prepare for that risk, and together we can stay safe this hurricane season. This has been Ken Graham right here at the National Hurricane Center in Miami, Florida.
Hello, my name is Jamie Rome. I'm a storm surge specialist with the National Hurricane Center in Miami, Florida. And today I'm going to be doing a review of the Unsurvivable hurricane season of 2020 and what's ahead for this season, 2021. But first, I'd like to thank you all for giving me a moment of your time today to talk about a topic that's near and dear to my heart, hurricanes, and more importantly, preparing for hurricane season. And here we are in May with hurricane season a mere days away. So this is an incredibly important topic before us, as well as getting ready. So let's first talk about a seasonal overview of what happened in 2020. There's just so much interest in what happened. We set so many records. 2020 was such a memorable season for so many reasons. First and foremost, it was record-breaking from the sheer number of hurricanes, 30 named storms. Remember when tropical cyclones reach a certain level, we named them. There were 30 such systems, 10 of which required storm surge watches and warnings for the continental United States. But the other thing, we couldn't talk about 2020 without talking about the intersection of the busy hurricane season in COVID. And for many of us, that meant adjusting the way we work or go to school or learn. And for you, you probably had to do a lot of your work or schooling from home. And we kind of had to adjust similarly. That bottom right-hand image there is my dining room at the height of hurricane season. And that just shows you that we were in storm surge working from home. That doesn't seem relatively eventful or noteworthy, given pretty much everyone had to work from home at some point during 2020 or during the global pandemic. But this was a big paradigm shift for the National Hurricane Center, because it's not just working at home, like, just writing documents and things like that. We actively issued warnings, specifically warnings that prompt evacuations from home, in many cases from that desk right there in that image. In fact, 9 out of 10 U.S. landfalling storms for storm surge were conducted completely from home, which is, I won't lie, it was pretty kind of scary because we weren't entirely sure how everything was going to work. And we really had to just change everything about how we worked, how we coordinated, the software we used. Just everything had to get changed up. For myself and the other federal employee in storm surge, there's only 2 of us. It required a lot of, this is just a snapshot of just to kind of give you a sense. Everybody at the Hurricane Center was working round the clock. In this particular, I just grabbed the statistic just to give you a sense of how much around the clock. We had, myself and the other storm surge specialists had over 700 hours of overtime, which you can divide that number by 40 to get weeks out of it, and it gets to be pretty much up there. So basically for about 3 straight months. All we did was eat, sleep, and think hurricanes. It was pretty rough. But the good news is, the success story is as of this presentation, there are only 2 known direct fatalities attributed to storm surge. And why is this important and relevant? It's because historically, storm surge accounts for 50% of the direct fatalities in hurricanes, yet there are only two non-fatalities attributed to storm surge, despite all this activity that last 2020 season. Just to sort of put it in perspective, there were 133 active warnings, sorry, not active warnings, but advisories for which a watch or warning was required. And this is just one way to measure the activity. There's several ways to measure and talk about the degree of activity. But to place this in context from the last couple of seasons, since 2017, the amount of warning activity, the number of warnings, the number of advisories that required a warning, it was about 2 to 3 times the normal. So if you can imagine 2 to 3 times the normal activity based off this one metric. By and large, the bulk of it, as you know, over in Texas, was shoved into the Gulf of Mexico. And the reason for this is there was a big ridge out over the Atlantic, big area of high pressure. So big high pressure out over the Atlantic. And it was strong enough that it tended to shove all of the activity, or most of the activity, with the exception to Isaias, into the Gulf of Mexico, and most notably, Louisiana. And in fact, there's one area in southeast Louisiana, Plaquemines Parish, that experienced or was under a storm surge warning 6 times in 2020. I've been doing this job for 12 years and been at the Hurricane Center for 22 years, and I've never seen that type of recurrence over and over again within one given area. And this is just a quick snapshot. The poor residents of Louisiana, it just seemed like it came nonstop. And in some cases, as was the case with Marco and Laura, the activity was like the 2 storms were right on top of each other, which really just made it difficult. But even after Laura, there wasn't a tremendous gap before we had Sally, 19 days, and then about a couple of weeks, 3 weeks before we had Delta, which made landfall in roughly the same area as Laura, and then ultimately ending with Zeta. So you're going to get a sense of the activity. And while not all this activity had an immediate impact on Texas, you often caught the periphery of it. So Texas had a pretty busy season too, just because you were on the edges and in some cases did experience the impact. But the season, I would be negligent in any sort of discussion of the hurricane season without talking about Laura. Laura was not only the strongest landfall of the season, but probably the storm that most defined the season because of all of the media attention that came with it, not only just within the United States, but globally. There was massive interest in Hurricane Laura, primarily due to the incredibly large storm surge that came with it, the catastrophic wind impacts that were experienced over portions of southwest Louisiana, and the rare use of very harsh language by the National Hurricane Center by ascribing it is unsurvivable. We've never used that type of language before, and I'm going to explain to you why we did so in the next few slides here. First things first, what actually happened during Laura? There's been a lot of misinformation out there regarding what actually happened. This little blue area on the map here, so this is southwest Louisiana. Texas is just off the left-hand side of the map, so it's just off to the west there. The blue area indicates the area of southwest Louisiana that had greater than 9 feet of storm surge. So When you think 9 feet, I stand 6 feet tall, so that would be 3 feet over my head. That's pretty impressive. Now, and look how large of an area that flood footprint covers. And what was really interesting about Laura is it occurred within an area that we don't have a lot of water sensors, meaning instruments that are in place to measure storm surge. And the ones that we do, there were really only 2, and one of them failed. So we really only had one instrument in place to measure this. And because it was on the edge, the extreme edge of the surge, that led a lot of people to wrongly diagnose the surge as had not happened, meaning they wrongly concluded that the storm surge didn't materialize. And that led to a lot of discussion in the days after Laura that was just not accurate. And so I'm here to help you with the facts and the data to help you understand what actually happened, because what we've learned over the years is if people don't understand what actually happened, they will misinterpret their risk going forward. So I'm here to set the record straight and tell you what actually happened during Laura. So the way we diagnose storm surge, especially for an extreme event like this, is really it requires boots in the field or boots on the ground, meaning people. It requires people to actually go into the hardest impacted area and do a damage analysis, because instruments either fail or in the wrong location. We often have to do a little bit of forensics to figure out what actually happened. That generally takes weeks to months. So this is how we do it. Where in my case, I didn't go into the field. This person photographed here on the right-hand side is a USGS scientist. And if you look on the image on the left-hand side, it looks like a rather boring, very dirty shower. But if you look closely on about the 3rd row of tiles up from the bathtub, there's this very straight line where below it looks very muddy or more muddy, and above it looks relatively clean. That is what's called a high water mark. And basically what happens is when the water floods a home, it's muddy and dirty, and so it leaves a debris or dirt line for every point under or below where the highest water occurred. So this is an example of the type of forensics that we would do in a storm, and it tells us how high the water was. And so you look at this image and say, well, that's not really impressive. That looks like about maybe 2 or 3 feet. You could stand up and be above it, except it was on the 2nd floor of the home. And that's where the image on the right gives you context. So they've taken in that little pink ribbon right near the person there is showing you where that high water mark occurred on that particular home. And to give you perspective, this is how high it is. So this is an independent team taking an independent analysis from that area. You can see just how high that mark was. That white looking pipe he's holding is a special measuring stick for measuring these types of high water marks, and you get a sense of just how high it was. The analyst here, he's taller than me, and I'm 6 foot, so I'm guessing he's about 6'2", maybe 6'3", just to give you a sense of how high it was. And the final measured storm surge from this particular mark was 17.1 feet. So take that in, 17.1 feet above ground, or above your toes, which is an impressive, probably the highest high water mark I've seen in my 12 years. So we take all that data and we put it in our models, and we basically run the model backwards, meaning historically. Like you're used to hearing about models running forward, like forecasting. We can also run them backwards to recreate historically what happened. And I'm going to show you here, this is the red area. We start with the, showing the area which got that 17.1 feet, surge, in this case greater than 16, is basically the highest surge occurred in the Creole and Grand Chenier area of Cameron Parish in southwest Louisiana. And if you're geographically trying to situate yourself here, Lake Charles is up towards the top hand portion of the screen, and Texas is on the west side or the left side of the image. And you can see the track here of Laura is in the red line here. So now I'm going to start adding other components of the flooding so you can see the total flood footprint. So now I've added the area greater than 12 feet, the area greater than 8 feet, the area greater than 4 feet, and then all areas that experience some level of flooding. Now, what's really fascinating about this image and the take-home message, why did I spend so much time building this narrative, this technical narrative, is so I could get you to this point here, this image. If you look at this image, it really is a tale of two cities, to quote Charles Dickens. Or on the left-hand side or west side of the track, there isn't much storm surge. And on the east-hand side or the right-hand side of the track is a ton of storm surge. And this is because the winds on the east side of a storm are blowing towards the shore, right? They're blowing the water towards the shoreline. It also tends to be where the winds are typically the strongest. And then on the left-hand side or west side of that image, they're blowing offshore. So they tend to be blowing water away from the coastline. And you can see just how much of a difference it makes where you are relative to the track. Now, if we could precisely predict where the track was going to go 2 or 3 days in advance, storm surge would be relatively easy. It would be relatively straightforward. Unfortunately, the limits of science, specifically the limits of predictability of hurricanes, won't allow us to precisely pinpoint where the track could occur. And so therefore, we often don't know where these big storm surges are going to go until right before landfall. And this is why sometimes you're asked to evacuate and it doesn't, maybe the flooding doesn't materialize quite as much. It can be very easy to become skeptical of hurricanes, hurricane forecasts and evacuations, after something like that might happen to you. But I'm here to tell you it's just a part of living near the shoreline, because we simply can't risk life by not evacuating on potential. And the limits of predictability really force us to do things that way. Because if you look at, for example, this little area on the map called Johnson Bayou, while they didn't get that much storm surge, maybe only a couple of feet, you could see how if this track were to wobble or move a little bit to the west, how that might have been drastically different. And in fact, let's take a look at that. So this is a case of what actually happened on the left. So in this case, it's called Hurricane Laura Best Track, which basically is how we say what actually happened. So it's an analysis of what occurred. And in the right-hand side, the right image, or what's labeled image B, is what would have happened had Laura shifted west 20 miles. So the left is what happened. The right is what could have happened if Laura would have shifted west 20 miles or wobbled west. So 20 miles is not a big shift. It's a very small shift. And you can see the dramatic difference in the storm surge that would have occurred in that area that I just highlighted there. And in fact, if you subtract these two images, so if you just take these two and subtract them, you get this image. So this purple line is what Laura did, and this blue line is if we were to shift it over 20 miles. And then these colored areas are the difference in the storm surge that would have occurred had Laura moved west 20 miles. And you can see this bright pink and red area specifically means that 10 to 15 more feet of surge. So imagine 10 to 15 feet more water would have occurred if Laura would have simply wobbled to the left or west. So you can see why we had to, sound the alarm over in this area. And many of those residents had to evacuate. And it would be tempting for them to say it was an evacuation for naught or it was a waste. But you can see from this image that if the storm would have just wobbled just a little bit, they too would have experienced that unsurvivable storm surge that was experienced over in Cameron Parish. But was it really unsurvivable? So we've talked about how much water they got. Now I want to talk to you about how fast it came up. So here's another one of those high water marks I was telling you about. This is a different site. You can see, if you look really closely in this image, you can see kind of grass kind of hanging off of this, the underside of the house. That's, again, the types of forensics that we might use. But we also had more data. There was an instrument over in Mermitau River, which is near Grand Chenier in Cameron Parish. And so it's measuring, it's doing its thing, right? So there's low tide, high tide, low tide, high tide, low tide, high tide. So it's, it's kind of doing its thing, just measuring tide. And you get over here on August 27th, and you see this very rapid rise on the far right-hand side of that right image. That's a rise of 8 feet in 1 hour, 8 feet. And in fact, because of the limitations in the sensor, the water rise was so fast that it basically overwhelmed the sensor. The actual water rise, as evidenced by forensics after the fact, was probably closer to 9 or 10 feet in that hour. So think about this. Think about the water rising 9 feet in 1 hour. That's kind of up there with the rate at which a tsunami comes inland, the briskness of the speed. And this is probably the fastest I've ever seen a water rise, measured at least, in my time as head of storm surge for 12 years. This is absolutely unsurvivable, because any home that wasn't elevated would have been completely flooded, completely inundated, and the occupants would have been forced vertically, meaning like up on the roof, or out of the house into the raw elements of that water and wind. And you can, I can just tell you from experience that once you are forced out of your home, vertically or horizontally, the chances of survival are really, really, really low. Because the water has all sorts of debris in it. You can be cut, you can be shoved around. The velocities, the rate at which the water is moving around is really, really, really fast. So that is, in my opinion, the epitome of unsurvivable. It's not just the height of the water, it's the rate at which it comes up and inundates populated areas. So this is a before and after. So on the left is a shot of before the hurricane impacted the area. On the right, you can see it afterwards. And the reason I show you this, if you look closely, you can kind of see some buildings in the before image, and on the right-hand side, they're gone. They're gone. And that speaks to the force at which the water comes in. It typically will sweep the house off its foundation, and what you're left with is nothing but a concrete block underneath it. And you can see it. Some of these homes are completely pushed off their foundation. In some cases, they don't push them far. In other cases, they completely disappear in the storm. So if you were an occupant or stayed in that home during the storm, the chances of survival were really, really quite low, which is why we tag that phrase unsurvivable to it. And the other misconception that was propagated after the storm is that nobody lives in the area that experienced this catastrophic storm surge. But in fact, according to the census information, about 7,000 people occupy the area hardest hit by that area. And I think this is probably the most important statistic in here is 35% of the residents are manufactured homes, which means they would not stand up very well to the winds. And it also means they sit flat on the ground. They're not elevated, which means they would have been completely inundated by that water. And much of the entire population of the 7,000 much of them, in fact, nearly all of them, are susceptible to storm surge. Yet, despite basically 7,000 people were susceptible and exposed to this catastrophic storm surge, there are 0 direct fatalities, 0 from storm surge during Laura. And in fact, we've gone back and surveyed and asked our partners and emergency managers in emergency management, first responders, and we don't know of any rescues that happened during and after Laura. And what that argues is a near 100% evacuation compliance, which is unheard of in my line of work. Typically, at best, we would hope for like 90% evacuation compliance. Would be normally considered a good evacuation compliance. So if we were to assume that 10% would normally say, so 10% of 7,000 is about 700 people. So you would normally expect about 700 people to have remained during this particular storm, and yet we have 0 fatalities. So I'm going to argue that the use of Unsurvivable was warranted and probably saved a lot of people's lives during Laura. Yeah, but what about Houston and Galveston? So this is probably what will go down as one of the greatest success stories in evacuation or non-evacuation in my time at the helm of storm surge. And so what you see on the left-hand side is the historical tool that emergency managers would use to make an evacuation decision for a case like Laura. And basically what this is showing you is if Laura would have moved closer to Houston, Galveston, they could have experienced that 15 to 20 feet of storm surge that we just talked about for the last several slides. And they would have historically evacuated or made an evacuation decision based off that 15 to 20 feet. You can see this little flag right here, it says 17. On the right is the real-time guidance that we were using during Laura to brief the emergency managers. And you can see it was showing considerably less storm surge on the periphery over in this Houston Galveston area, which is the area encircled in the black oval there. And this is why, among other things, Houston Galveston was able to hold off on unnecessary evacuations. Now, not evacuating people is critical in the best of times. It's even more critical during a pandemic, because you're basically talking about, had an evacuation order been executed, it probably would have been about 1 million residents would have been asked to leave. So you can imagine the dangers of asking 1 million people to get on the road and move, go to shelters, go to hotels, go to family members during a pandemic. The amount of exposure, the amount of what could have been done, harm could have been done to the community through that evacuation order. But thankfully, owing to radical advances in science and technology over the last several years, namely the prediction of hurricanes and the associated storm surges, we were able to mitigate that unnecessary evacuation for Houston Galveston. So a great, great, great success story that many people just simply haven't told that story. But we probably saved some lives in and around the Houston Galveston area through the non-evacuation decision. And the emergency managers in that area really deserve a lot of credit for that. So speaking of, we sort of started off this talk about mortality in hurricanes. Since 2017, when we really started to try to count, or try to look at how people were losing their life in hurricanes, there have been 14 U.S. landfalling hurricanes since 2017. You can see them down there at the bottom. I sort of listed them off by year. And this slide is actually a little bit out of date, including 6 major hurricanes. There's now 6 major hurricanes. If you recall, recently Hurricane Zeta got upgraded from a Category 2 to a Category 3. That makes it a major hurricane. So there's now 6 major hurricanes. So since 2017, 14 landfalling hurricanes, including 6 major hurricanes. During this time, there have only been 7 storm surge fatalities. Now, why is this important, and why have I spent so much time today talking to you about storm surge? Because historically speaking, the leading cause of death in a hurricane is storm surge. But that's starting to switch a little bit. And now we're starting to lose more and more people behind the hurricane or after the hurricane. So let me explain. In Laura, we lost more people due to carbon monoxide poisoning from generators in Laura alone than in storm surges from the previous 14 hurricanes. So more people, about I think maybe 14 or 15, died of carbon monoxide poisoning in Laura after the storm had passed than storm surges during the previous 14 storms. Why is that important? And why is that important for an educational or outreach talk like this? It is imperative that as you prepare for hurricane season, you understand generators and their proper usage. We're just seeing a large increase in fatalities due to improper use of generators because people are increasingly reliant upon power. And so power disruptions that occur after hurricanes or any natural disasters are causing people to buy generators, and many people just simply don't know how to use them or just using them improperly. So generator safety is really, really, really important. Generators emit a colorless, odorless gas called carbon monoxide, which if you run the generator indoors or run it in your garage, can be very, very, very dangerous. And it's a double whammy because it's colorless and odorless. You don't necessarily know that the carbon monoxide gas is entering your house, right? If you could smell it, you would be alerted to this danger. But because you can't smell it, or always, it tends to sneak up on people. So what happens is people improperly run generators in their homes, or they run them near air conditioning units, which suck that air in and pump it into the house, or they have their doors open to get circulation in the house because it's hot, and the winds blow that carbon monoxide into the house. So it's very, very, very important as we start in the 2021 season that you understand generators and their proper usage. So what's new for 2021? Some of these you've seen in the news headlines. Well, we've upgraded our storm surge models to do even better than we did last year. So we're going to try to do even better predictions than we did last year. You may have seen this last year that we used the Greek alphabet. We had so many storms, Zeta, Eta. We found a lot of people struggled with the Greek alphabet, often because the names sounded similarly. So we're retiring the Greek alphabet, and now we will use an auxiliary list if required. Hopefully we won't need it, but if we do, we have an auxiliary list to use more traditional names if necessary. Also, we're moving up the tropical weather outlooks. You've probably seen this already since we're already beyond May 15th to May 15th versus June 1. Now, we're not changing the start of hurricane season. A lot of media have wrongly reported it that way. We're just starting our outlooks on May 15th to, if we do have an early season storm, and we did have some early season, both a storm and a system, ironically enough, impacting Texas, that started prior to June 1. And so you can see already how this upgrade is manifesting itself in improvements in services. But we're not changing the start of hurricane season at this time, contrary to what has been reported. So this is a quick look at the new, and these are some big words, don't worry about it. This is just for scientists like me to make you think we know what we're doing. And so this is a quick look at how we've upgraded our modeling over the last couple of years. So the black line is Hurricane Laura, since we spent so much time today talking about Laura. And this black line is a representation of size. meaning how big the wind field is or how large the hurricane is. And you can see that last year when we upgraded the model, we did a really good job of the initial size, but the storm, the evolution of the storm size, we didn't always get it. With the new upgrade that we're starting this season, you can see that we've done a much better job of those colored lines, the blue, green, and red, basically encapsulating or covering the black line, which is what actually happened. So we feel really good about this, and we're really excited about this particular upgrade. So in conclusions, despite a record-breaking season, there were only 2 direct fatalities attributed to storm surge, despite it historically being the leading cause of death in a hurricane. And this continues an overall trend of declining direct fatality ahead of the storm and during the storm. And instead, we're seeing increasing indirect fatalities after the storm from things such as generators, cuts, heart attacks, heat exhaustion, overexertion, trying to cut down trees from the house and the tree kind of falls. So remember to be very, very, be very aware and safe in the days after. It's often quite hot, and you can overextend yourself and hurt yourself in the cleanup process. And then I'm going to conclude with we're upgrading our modeling system in hopes of doing a better job of predicting these storm surges going forward. That concludes my presentation today. I again want to thank you all so much for giving me a portion of your time today, your attention, and I please ask that you be aware and safe this hurricane season. You can always get information regarding current threats and forecast information from hurricanes.gov. Hurricanes.gov is the website of the National Hurricane Center, which will provide you the latest information regarding the forecast and threats. And with that, I will turn it back over to the organizers and conclude my presentation. Thank you so much.